Hi everyone, Mrs. Houston here with our Regents Review. Question 15. Ian throws a ball up in the air and lets it fall to the ground. The height of the ball, h of t, is modeled by the equation h of t equals negative 16t squared plus 6t plus 3, with h of t measured in feet and time t measured in seconds. The number 3 in h of t represents. So we're trying to figure out what this 3 represents here. And I got that sign there, that's a positive 3. It's the same as this 3 right here. So we have the maximum height of the ball, the height from which the ball is thrown, the number of seconds it takes for the ball to reach the ground, and the number of seconds it takes for the ball to reach its maximum height. All right, a couple thoughts I have on this one. First, I want to relate it to equations. This is like the general form of a quadratic equation, kind of similar to y equals mx plus b, right? We have this y equals ax squared plus bx plus c. You may not talk about that as much as y equals mx plus b, but what we do know is that this number is the y-intercept in a linear equation, and it's similar in a quadratic. This number right here is also the y-intercept. So if that helps you to know that you're looking for the y-intercept. Another thing, h of t equals, same thing as if it said f of x equals, g of x equals, okay? Remember, anytime you see something like that, it's the same as y equals, and you're going to want to use your calculator. We can use y equals for all kinds of stuff. So clear out whatever's in there, and then don't lose that negative sign. It's negative 16x squared plus 6t, and we're going to use x. I didn't even say that before, but remember, when we type into our calculator, we just change the variable to x. And then plus 3. Okay. Take a look at the graph. There it is. It's kind of small, but I'm going to bring that over. You can also take a look at the table. And since this is a real life situation, negative, remember the x or the t is the time. Negative time doesn't make sense. We're going to start at time of 0. So I'm going to bring that down a little bit. Okay. So, and this table isn't the most helpful, but if we take a look here, this is when the ball was thrown, and if you think about the situation, so the height of the ball goes up a little bit, and then it comes down, and it hits the ground, and we can actually see that, because the ground is a height of 0, okay, and then here it's going below, so it goes up and hits the ground in less than a second, which is kind of crazy. Okay, so if we kind of take a look at the different parts, the 0, 3 here, oops, I'm trying to write on that and it's not letting me, but I'll bring that over too. Get rid of this. Okay, so the 0, 3 here, that's right here, that's where the, that's when the ball gets thrown. Okay, and then we can't, like I said, we can't really see the other spots, but here would be the ball goes up and it gets to this high point, and then the ball starts coming down, and here it hits the ground. And I know it's kind of hard to see because the graph is so small, but is 3 the maximum height of the ball, which would be up here? Okay, hopefully you can see that that's 1, 2, 3. It goes up a little bit there. Now you can't see it so good because I wrote all over it, but it goes up from 3. So it's not the maximum height of the ball. 2, the height from which the ball is thrown. That is our answer. Okay. The number of seconds it takes, that would be down here on the x-axis, and it takes less than 1 second actually to hit the ground, so it's not 3. And then there's something else about time here. The number of seconds it takes the ball to reach its maximum height, again, that's here, So if we come down to look at how many seconds that is, it's also less than 1. All right, number 16, 32 teams are participating in a basketball tournament. Only the winning teams in each round advance to the next round, as shown in the table below. So if we take a look at our table here, we see that there's 32 teams it starts, because 0 rounds means right at the beginning. After 1 round, there's only 16 teams. After 2 rounds, there's 8 teams, 3, 4 teams, 4 rounds, 2 teams, 5 rounds, 1 team left. That's the winning team, right? Which function type best models the relationship between the number of rounds completed and the number of teams remaining? All right, so hopefully you're kind of noticing a pattern here in the numbers. Talk about that in a second. But real quick, I want to talk about absolute value, choice 1. That would be a graph that looks like this or like this. Okay, so the key thing why we can eliminate this is that the values would go down and then come back up, or they would go up and then come back down. So they're not increasing and then decreasing, or decreasing and then increasing. Okay, the same with a quadratic. That's the U shape. It would have to decrease, increase, increase, decrease. Okay, so it's not quadratic. That leaves us with linear and exponential, and we talked about those a lot. Remember, a linear has a constant rate of change. Okay, it's adding or subtracting the same number each time. And then exponential is going to be multiplying or dividing each time. Okay, so real quick here, you should be able to see we subtract 16, then we subtract 8, then we subtract 4. So it's not a constant rate. Maybe you noticed at the beginning that it was dividing by 2 each time. Okay, if you think about that, that makes sense in a tournament. 1 team wins, 1 team loses. So you end up with half the teams after every round. Okay, so that means our answer is exponential.